So remember that a vertical asymptote, looking at the graph, is an imaginary dotted line that goes up and down. That's why it's called vertical. Today we're going to be looking at the equation and figuring out where the vertical asymptotes are. And it's actually easier than holes. Now that you know where the holes are, actually that worksheet you just did, or working on, if you know how to figure out the holes, you know where the asymptotes are. It's where you set the denominator equal to 0. If you plug that back into the numerator and you don't get 0 back, that means that x value is your asymptote. That's the gist of this lesson.
So it's like the shorter version of finding the hole.
Yes, and it doesn't have a y value.
It's the only part that I know how to do of that whole thing.
Yeah, so an asymptote doesn't have a y value, so you don't have to do the factoring, you don't have to do the canceling, you don't have to plug it back in. So let's go ahead and look at the first example. See if I can make it a little bit bigger. We have f of x equals 5x minus 2 on top. And we want to figure out what the vertical asymptotes are of f of x. By the way, just as a review, what would be the horizontal asymptote? Does anybody remember that rule? Because we are going to be applying that.
Since the squares are equal, you have to do a thing, right?
Yeah, the powers are equal, right? So you just divide the coefficients. So it would be y equals 5/3. That's just a refresher. That's not this lesson. We're looking at vertical, but remember, that's just how you find horizontal. So the question is, how do you figure out the vertical? Well, step 1 is going to be the same as holes. Set the bottom equal to 0, solve for x. All right, so we're going to take 3x minus 6 and set it equal to 0 for the first step. All right, so how would you solve from there? How would you solve for x?
Add 6.
Good. Add 6 and
Then divide by 3.
divide by 3. Right. I'll give you a second to copy this step down. We're going to set this equal to 0 and solve for x. For step 2, add 6, divide by 3, x equals 2. Now notice, I have this labeled. This is a possible vertical asymptote. Why? Because it could either be a hole or a vertical. You have to plug it back into the top to see. And yes, I know that there are a lot of different rules to remember. That's why we're going to spend a day on reviewing this stuff. But just remember that the first 2 steps for holes and vertical asymptotes are the same. Set the bottom equal to 0 and solve for x. And even the third step is the same. You're going to take that number and plug it back into the numerator. Okay, so going back to the original problem, here's the numerator. We're going to take x equals 2, plug it back in up there. Let's read this together. Step 3, plug x value into the numerator. If you get 0 back, it is not a vertical asymptote. It's a hole. We already learned that. If you don't get 0 back, then it is a vertical asymptote. So we got x equals 2. We're going to plug that back into the numerator, 5x minus 2. So it's going to be 5 times 2 minus 2 equals 8. So again, to reiterate, since we did not get 0 back, it's going to be a vertical asymptote. Therefore, at x equals 2, there is a vertical asymptote. And if you were to sketch that asymptote, you would go over to x equals 2 and you would draw a dotted line going up and down. I know there's probably some questions on that. Let me know if you have any. Again, it's a hole. It would have been a hole if you got 0 back. That's what we just learned. Because we didn't get 0 back, and by the way, it doesn't matter what that number is. It could be a negative number, a positive number. As long as it's not 0, it's a vertical asymptote. So again, there's going to be a vertical asymptote at x equals 2.
You need these rings?
Wait, that's the end of it? That's all we have to do?
That's all you have to do.
That's like the easiest part in the whole thing.
Example 2. We got this equation.
The second half of the holes part.
We're going to determine the vertical asymptote of this equation. Same steps, so you don't have to rewrite them. So yeah, f of x equals x cubed minus 5x on top. and 4x squared minus 9 on the bottom. So what's the first thing you're going to do?
You gotta set the bottom to 0.
Set the bottom to 0. So you're going to take the bottom set equal to 0, so you're going to have 4x squared minus 9 equals 0. Remember, if you just have one x term in the equation, you can add the constant term to the other side and then solve for x. So that's what we're going to do. You don't have to factor. If you're solving an equation and it only has one x term, you don't have to factor. You can just get x by itself. So the first thing you're going to do is add 9 to both sides. Okay? So you get 4x squared equals 9. Then to get x by itself, you divide by 4. So you get x squared equals 9 over 4, which is a fraction, I understand. Then you take the square root of both sides to get x by itself.
Could you, like, square it first? Because I squared it first and I still got 3 over 2. Instead of getting 9 over 4. Like, I squared it with the 4 there. And then I squared 9 and I got 2x. Well, I don't know if that would even
Well,
make sense.
the 3 over 2 is simplifying 9 over 4.
Yeah. Yeah, you have to do it in that order. So when you take the square root, I need to really, really emphasize this right here, plus or minus. Okay? For example, if you take the square root of 9, it can be 3 or negative 3, because negative 3 times itself also gives you 9 back. So every time you take the square root and you're solving for an equation, do not forget the plus or minus. So when you take the square root of a fraction, take the square root of the top, which is 3, square root of the bottom, square root of 4 is 2. That's all you have to do to take the square root of a fraction, just to reiterate that. And because it's plus or minus, you end up with 2 possible x values for this one. Either x equals 3/2 or x equals negative 3/2. So who remembers the next step after that?
You plug it into the numerator.
So we have to plug both of these into the numerator to see if we get 0 back, right? If we get 0 back, we know they're wholes. If we don't get 0 back, then we know they are vertical asymptotes. So
I'm gonna have to wait. I'm an idiot.
we're going to plug 3/2. It doesn't matter the order. You can plug in negative 3/2 first. We're going to plug in 3/2 to the top. So it's going to be 3 over 2 cubed minus 5 times 3 over 2. And if you want to, you can use a calculator, okay? But you can also work this out without a calculator. 3 cubed is 27, 2 cubed is 8, and then 5 times 3 is 15 over 2. In order to subtract these, you have to find a common denominator, so the right becomes 60 over 8. And from that point, I can tell it's not going to be 0, okay? It's going to be negative 33 over 8, which is not 0. So again, that number doesn't matter, but what it tells me is since it's not 0, that means the number I plugged in is a vertical asymptote. So this has a vertical asymptote at x equals 3 over 2. But we also have to check the negative 3 over 2 to make sure it doesn't give us 0 either. Halves. If you plug in negative 3/2 to the top, you get negative 3/2 cubed minus 5 times negative 3/2. It's a lot like the previous one, except it's negative 27 over 8 plus 60 over 8. But either way, you still don't get 0 back. So both of these x values are vertical asymptotes. Both x equals negative 3 over 2 and x equals 3 over 2. So when you graph these asymptotes, you need to convert them to decimals. Not that I'm asking you guys to graph them. In the future we will. But remember, both of those ended up being asymptotes. 3 over 2 is just 1.5. So if you were to graph these, there'd be an asymptote at 1.5 and negative 1.5. And we're going to do one more example. This one actually ends up being easy. I can already look at the equation and tell. It's going to be simple. Asymptote. ASYMPTOTE. All right, final example. We have f of x equals 1 over 2x squared minus 5x minus 6. All right, I have a question for you guys. Will the top ever equal 0?
No. Yes.
Maybe. Because you can't plug anything else in it. It's always going to be 1.
It's always going to be 1. It will never be 0. So listen up. Whatever you get down here has got to be a vertical asymptote. You'll never get 0 on the top. Okay? If there's just a number on top, whatever you get on the bottom has to be, right? There's no hole. There can't be a hole. It's just going to be a vertical asymptote. But the question is, how are we going to solve this? We'll go to that in a second. Still going to set the bottom equal to 0. When you have a formula like this, how do you solve it? It's not. Okay, factoring or quadratic formula. Factoring sometimes works. Quadratic formula always works. So we're going to use a quadratic formula here. Your A is 2, your B is negative 5, your C is negative 6. Anybody remember the formula? All right, so here we go. A is 2, B is negative 5, C is negative 6. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. So I'm going to plug in negative 5 for B, 2 for A, and negative 6 for C. And simplify. So inside we get 25 plus, because it's minus minus, plus 48. Get a 4 on the bottom, and then the first negative B becomes positive 5. I'll stop there and let you write all that stuff out. So 25 plus 48 is the next step, which is 73. Listen up. You will need a calculator for this, okay, to figure out the square root of 73. So you could just leave it this way. These are going to be your 2 vertical asymptotes because the top is 1. We'll go over that in a second. But in order to try to figure out kind of where those asymptotes go, you would need a calculator. Just to demonstrate, we'll do this one. 5 plus radical 73 over 4. So Desmos calculator, like to use that one. You could do, now because the top involves 2 terms, I'm going to put in parentheses, 5 plus, and you can actually type in SQRT, it gives you the square root.
Wow.
5 plus the square root of 73, and then outside of the parentheses I'm going to divide by 4. It's going to give me 3.38.
How handy.
You can do the same thing with minus, just to get 2 different decimal values back, so that when you go to graph it, you'd be able to figure out kind of where those asymptotes go. But again, like we talked about, like I heard you guys say, you can't plug those x values back into the numerator. There's no x value. Since you can't plug them back in and it's always 1, the numerator will always be 1 and never be 0, so these 2 end up being vertical asymptotes. And again, that's always going to happen when the numerator is a constant number.